Okay, this graph actually represents the audibility of our human ear. So that means if we actually look at the graph on the actual book, that's much more detailed. So this is just a rough diagram of that. But if we look at the graph, we see that, let's say, 1000 is around here. So at 1000 hertz frequency, this corresponds to 0 decibel. So that means for 1000 hertz frequency at 0 decibel, we'll be able to hear the sound. And if we look at it closely, we'll see that at 100 decibel, so let's say that's 100. At 100 decibel, we see that it's approximately 40. So that means we need 40 decibel to hear a sound at 100 hertz, right? So for our case, if we, and then we have this unit called phones. And to understand what phones is basically a unit of loudness level. So it's numerically equal to the sound level in decibel at 1000 hertz. So for example, if this is 1000 and we know this is 0 decibel, so the phone unit or the loudness level here will be 0. So the phone unit will be 0. And if we look at the actual graph, we'll see it goes like 0, 20, 40, 60, 80, and so on and so forth. Uh, so we're concerned about 100 hertz at 50 decibel. So if we try to match that from our graph, we see that at 0 hertz 50 decibel we get about 20 phones, right? So let's say this line right here, let's say, just give me 1 second. So let's say this line right here is 20 phones. Now what we need to do is we need to see what happens, how much decibel we get for 5000 hertz tone, right? So we see 5000 will be approximately here, and if we try to match that with our um, y-axis, which is the sound level, we get approximately 20 decibel. So for 5000 hertz and 20 phones unit, it's going to be 5000. Just give me one moment. There we go. So it's going to be 5000. So for 5000 hertz and 20 phones, our sound will be 20 decibel. And well, this is not an exact answer, because the graph is just an estimation, so the answer might vary a little, but mostly the sound should be close to 20 decibel.